Hello everyone, we will continue our discussion about the velocity time graph. So velocity time graph we have seen for this uniform velocity or constant velocity, and for that case, if you want to calculate the magnitude of the displacement, that will be the area of this rectangle ABCD, which is under the velocity time graph or under this line. Then we have studied for uniformly accelerated motion where velocity is increasing, and the plot it shows that when the time interval is dt and the corresponding change in velocity is dv, and if I take the ratio dv divided by dt for this first time interval, that ratio if I compare with time interval dv divided by dt for this second duration or second time interval, so ratio of the dv divided by dt for second case and dv divided by dt for this first time interval, that slope is constant. So here for the first time interval dv divided by dt ratio, and for the second time interval dv divided by dt, the ratio dv by dt, it is constant for the both interval or it is same. So that I can say the slope of this line is constant, or there is equal change in velocity in equal intervals of time. And then this motion, we will call it as a uniformly accelerated motion. Here, velocity is increasing. Velocity is increasing, but acceleration is constant. That's why we will say this as a uniformly accelerated motion with increasing velocity. Velocity it is increasing, but slope of this line is at any segment or at any interval you take the slope of this line or you calculate the magnitude of the acceleration, it will be constant. Here velocity is constant, here velocity it is increasing. So in this video mainly what we will discuss, here we have discussed about constant velocity, here we have discussed about increasing velocity. Now we will consider two more cases. First case is when velocity is decreasing, and fourth case is where velocity is increasing and decreasing. Such kind of behavior is there that we will study. So first let us study when the velocity it is decreasing. As you can see in this graph is also velocity versus time only. But for this graph where velocity it is decreasing, you can see as time is increasing, time is 1 second, 2 second, 3 second, the corresponding velocity if you observe, there is a drop in velocity, or velocity it is decreasing as time is progressing or time is increasing. Now, one more question. Why we have called this motion as a non-uniform motion, non-uniform accelerated motion? Here we have said uniformly accelerated, but here we have said non-uniform motion. Why? What is the reason? If you observe the slope of this line, the slope of this line is positive, but the slope of this line it is negative. That is the first thing. Second observation, if you do, the line here, this line, actually it is, suppose these all small points are there, if I consider them as a small circle, this line is passing exactly through the center of these points or center of these small circles, exactly passing through the center of that points, this line. But same line if you observe here, this line is not at all passing through these points, exactly through the center it is not going. I can say simply this line is tangential to these small points, right? The velocity here it is decreasing, here velocity is increasing, but the thing is here the slope is positive, here the slope is negative, and here how we have said that dv divided by dt ratio for any time interval it is constant. What about this graph? Now, suppose for understanding of the dv divided by dt, simply if I connect the segments, what this segment indicates that the velocity has decreased from 20 to somewhere here. Then it has decreased here. Then it has decreased here. Then it has decreased. Then it has decreased. Then it has decreased. Then it has decreased. Like, like that, there is a drop in velocity. Now, Here we are almost one, two, three, four, five, six, seven. Seven small segments we have, or small lines we have. Now, if I calculate the slope of this each individual line, or each individual segment, whether the slope of that lines, or the ratio dv divided by dt. For this line, if I consider, this is the change in velocity, but it is in a negative direction, and this is the corresponding time interval. So if I calculate dv by dt for this segment, and if I compare that segment with any other segment dv by dt ratio, whether they will be equal? No, because here for every line or every segment, the slope of these lines are different, and here velocity is decreasing. That's why we'll call this motion as non-uniformly accelerated motion. Here it is uniform. dv by dt ratio, here it is uniform. But here the same dv by dt ratio, or the slope of the line, they are not constant like here. Here it is not constant. That's why we will call this motion as a non-uniformly accelerated motion, where velocity it is decreasing. Right? Few more things are there. We will discuss in the next video. Thank you.